Hello, good afternoon, everyone. Let's get started. Let's begin with a few practice questions just to refresh our memory a little bit before we learn the new stuff. So give me a moment here. Okay, let's try this question. Okay, I'll read it to you first. In beans, broad pods are dominant to narrow pods, and red flowers are dominant to yellow flowers. Cross a plant with heterozygous broad pods and yellow flowers. So that's going to be our first plant right here, heterozygous broad pods and yellow flowers. And the second plant is going to be narrow pods and heterozygous red. So let's do the first parent right here. It is heterozygous broad, and broad is big B. And since it is heterozygous, it will be big B, small b. And we have yellow flowers here. The question does not specify whether it's homozygous or heterozygous yellow flower. However, because yellow flower is recessive, the only way for the trait to show up is if it is homozygous. So that's the genotype for the first plant. The second plant has narrow pods. And once again, because narrow pod is recessive, then we know it is going to be small b, right? And for the heterozygous red flower, it would be capital R and small r. So it's important in the on the test to correctly write out the genotype of the parents before you get too far ahead, too deep into the question. You're gonna make double check that these are correct. Otherwise, the whole question will be wrong, right? So let me write them here again. That's one of the plants, and this is the other one. And the next thing you have to do is to write out the gametes. Okay, gametes. And for the first plant here, there are two possible gametes, big B, small r, and then the other one is also big B, small r, so you don't have to write it. Right? We only have to write it once, big B, small r. And the other one is small b, small r, right? Small b, small r twice. And like I said, we only need to write it once. We do not need to repeat it. What would be the gametes for the second plant? Let's take a look here. Anybody want to tell me the gametes for the second plant?
Small b, big R.
Very good. Yeah, there's small b, big R, and small b, small r, right? There we go. Now if we do it again, it's going to be the same two things, so there's no need to repeat it. Right? So you see, these questions, we call them dihybrid because we are tracking two traits at the same time, but it's not always necessarily going to result in that big, 4 by 4 tables that we did last week. It really depends on the genotype of the parents and the number of gametes. So in this case, we are just going to have uh, a 2 by 2 table, 2 by 2 table like so. We're gonna put the gametes of one parent over here. It doesn't matter if you put on the side or on the top, um, but you just have to be, um, consistent. And over here, small b, big R, small b, small r. And then we're gonna go ahead and combine them. Remember, the same letter goes together, and capital letter go first. So big B, big R, small r. Similarly, we're going to have big B, small r, and so on and so forth. Okay. And over here, if we want to figure out the genotype, it would be 25% big B, small b, big R, small r, 25% big B, small b. Basically, just copy them, right? And as long as they're not the same, then you can count them separately. Okay, I'll give you a moment to catch up. And yes, Manisha, go ahead.
Is it okay to write small and capital later whenever you, because on the top or when you're writing a gametes over here, it's a small B, big R, and then down is when we are crossing, it's a small, big R, small R. Is it okay to write like a small capital letter, like a whenever you want it,
Like
or
this,
there's
like
a
that. Sorry,
certain rule?
sorry. I don't. One more time, please. Yeah, I may.
So
Um,
on the gametes, you wrote it small b, big R, right? On the second one,
small b,
big
big
R.
R.
So my question is, do we have to write small b, big R, or we can write like a capital letter first or small letter later?
Oh, you mean like that?
Yes.
That's fine. I mean, like I
Doesn't
no, it doesn't really matter. When you put it in
because
here,
normally you said we have to write capital letter first and then small letter
for
second.
the same letter. So like if we are not gonna write like this, okay? Like if it's the same letter, we will write a capital letter and then the small letter. Okay?
Okay.
I
Okay.
understand your question now. Like you're asking me why we don't write big R before small b here, right? That's
Yes.
that's because they are different traits, different characters,
Mm.
and it's okay if they're different characters to put the small letter first. Okay?
Okay. Thank you.
Yep, yep. Phenotype. The first one is, I mean, there's a capital B here, so that would be broad, and red. And then second one is broad and yellow. And then narrow, red, and narrow yellow. Okay. Okay. I would understand you on the test. Okay. Like you don't have to write like broad odds or, flowers. Like I would get it. All right. If that's an issue. Um, questions? All right. I will give you another one to try. Okay, go ahead, please. How about 5 minutes? All right. Just message me or ask questions if you're stuck. Well, you can private message me. Okay, so 5 minutes. All right, that was about 5 minutes. That should be a reasonable time to spend on a question like this, on the quiz or on the final test. Anybody have answers they want to share before I move on? All right, that's fine. So let's take a look at the parents here. We have guinea pig, that's smooth coat, and wifer, and then the other one is heterozygous smooth and heterozygous black. So for the first one, smooth coat, smooth being dominant, and in bracket it says heterozygous, so that has to be big S, small s, and it's going to have white fur, which is a recessive trait. So that means it's going to be small b, like that. We're going to cross with heterozygous smooth and heterozygous black. Okay. Does anyone have any question about the genotype? If you don't understand why the genotype is the way it's written, you should ask me now. Okay, and then we have the gametes. Okay, so this one has two gametes, big S, small b, and small s, small b. I can trace it out for you if it makes it easier. You don't have to do it twice because it's the same thing, right? And over here, this one has four gametes, big S, big B, big S, small s, big B, and small s, small b. So in this situation, we are going to have a total of 8 different combinations. Right? I mean, like we don't know if they're different, but there will be 8 combinations. All right. So the 8 combinations will go into a table, 4x2 table, basically. Okay, so these ones I'm gonna put on the side, and then these one goes here. Okay, do them nice and big on the test so it's not so crammed. It's easy to make mistakes when you don't have enough space. Okay, for those of you who done it, please double check my work. There we go. Can you guys confirm this with for me? Did you get the same thing? Just give me a thumbs up, give me a yes. Okay, I have a few people confirming. That's good. Thank you. All right. So that's the right answer. No, not right. Let's see. Okay. So if you didn't get the answer, please ask the question. I can clarify for you. Is there a particular part that didn't make sense to you particularly? Okay. Well, feel free to pop the question anytime. Um, so we're not going to do the genotype for this one. It's only asked for a phenotype. So we're not going to do the genotype. We're only going to do the phenotype here. And this first one, you might want to bring a highlighter to the test to, help you out. This is smooth and black. And we want to see if there are other smooth and black. Basically, we need to look for capital S and capital B. So there it is. There is another one. And I think that's all. Okay, so I'll put it right here. Uh, big S is smooth and big B is black. And what's the fraction? Can someone give me the fraction and the percent? Anyone has that?
37.5.
That's right, which is 3 over 8, I believe. Okay, 37.5. And you just have to key in 3 over 8 into your calculator and then times 100. Okay. Another phenotype right here. This is smooth and white. Can I write the genotype? The reason I don't write the genotype is because all of them are different, right? So it would be like writing each one more time, but like I would have 8 different genotypes, and each one would be 1/8, which is 12.5%. Okay. So it's in this particular question, it's more useful to kind of group them by phenotype instead. Does that make sense, Manita? Like in the previous one, it was only four, so it's okay to write it out. But for here, like if I have to write out, it's like eight, right? So um I am it's unlikely I would ask you to do that on the quiz because it would take up too much of your time. So this is once again smooth and white though. White. 3/8, 37.5. And just very briefly, we have this one here. What is this though? Hmm? What's the phenotype of that? For the green one right here. Small s, small s. So it's not smooth. It is rough, rough and black. And that's 1/8, 12.5. Similarly, here we have smooth though, smooth and white, which is 1/8. Now I want to caution you. Oh, sorry, not did I?
Yes, you
Yeah,
did.
I made a mistake, right? This is rough, right? Rough and white. Rough and white. There we go. Now I want to caution you, the 9:3:1 ratio that I taught you last class will not work in these situations. This only works for parents that are heterozygous for both characters. Do you understand? This parent is heterozygous for both, but this is not, right? This is heterozygous for the smooth and rough, but it's homozygous for the black and white. So I cannot use the 9:3:1 ratio. I can only, I mean, the only way to do the question is to draw the table. Okay. Are we good, guys? Any, anything you want me to clarify before we, keep doing harder stuff? No meiosis on the quiz, okay? No meiosis. It's just it's whatever I post on Luminate, okay? All right. I think there's another question we have to try from the PowerPoint. Okay, so let's do a few more just to, help you out right here. Okay. I'll read it to you and then we'll try to figure it out along the way. In bees, normal wings are dominant to vestigial wings. We haven't done this one yet, right? I'm confusing with my other class. No, I don't think we did this. Okay. Anyways, normal wings are dominant to vestigial wings. Again, like you don't really care what vestigial means. They mean like tiny wings, okay? The key thing here is normal wings are dominant, okay, over these vestigial wings. So I have to go normal, and then you can say versus, well, it's greater than we know. It's dominant over vestigial. And you can choose whatever letters you want, okay? I'm gonna use big N for normal wings, and that means vestigial is gonna be small n. We have to use the same alphabet for the same character, okay? And then the other character that we are looking at is the pollen sacs. The pollen sacs can be deep, which is dominant over shallow. So we can put deep is dominant over shallow. Okay, so capital D right here and small d. You have to come up with the appropriate letters before you do the question. What are the parents here? So we have a bees with vestigial wings and shallow pollen sacs. The other bee is homozygous normal wings and heterozygous deep pollen. Okay, I'm just gonna do this one with you instead of letting you try because we don't have too much time. Vestigial wings. Vestigial wings would be little n, little n. It doesn't tell you whether it's homozygous or heterozygous because there is only one way to be vestigial. Okay, it's a recessive trait. Has to be pure. Shallow pods will be shallow pollen sacs. That would be little d. Cross. The other parent would be homozygous normal wings. Homozygous is the same. And heterozygous deep pollen sacs. So that's big D, small d. Okay, I think I did that right. Gametes. This right here is small n, small d only. There's nothing else. Okay, I'm using a bar to separate the parents. Over here, we have big N, big D, or big N, small d. There's nothing else. So our Punnett square is going to be very small. And not everything is 4 by 4. Not everything is 2 by 4. It really depends on the parents. So small n, small d goes on the side. And then the other two goes here. Capital letter first for each of the character. That. It's asking for the genotype and the phenotype. This is fine because there are only two. It's not a big deal to write them down. So that's 50%, 50%, which translates to, in this case, the same thing, 50% normal wings and deep pollen sacs. And then the other 50% would be normal wings again, but shallow. Is this okay? Please let me know if you need me to explain. I can. Don't be shy. All right. Okay, I'm just gonna go on then. Over here, example 5. Assume curly hair is dominant to straight hair. So curly, dominant to straight. Okay, big C and small c. And the other one is normal skin pigment and albino, okay, which is when you don't produce skin pigment, it looks very pale. So normal skin is capital N, and then albino or albino is going to be small n right there. So let's take a look at the situation here. A person with, a woman with curly hair and albinism, and then we have a man with straight hair and normal skin. Okay, so let's write it down first. Woman is curly hair. So we know she has a big C for curly, but I cannot tell immediately whether she's homozygous curly, like big C, or if she's heterozygous, which would be big C, small c, right? So I don't know yet. I'm just gonna leave it as blank for now. And then she has albinism, which means it's gonna be small n, small n. What about the man? What about the man? Okay. Anybody want to tell me the genotype of the man? You can do it. You can still answer questions just like you're in class, because I can see you. No need to be weird. What's the Okay, there we go. Thank you, Angelica. It's small c because he has straight hair and normal skin. But we we don't know. We don't know if it's big N, which would be normal skin, or he could be big N, small n, and it would still be normal skin, right? So at this point, we cannot say definitively which one it is. So I'm gonna leave it blank. That's the key thing to understand in this question, right? We only know it's one big C, at least one big C. We don't know what the other one is just yet. Okay, what about the kid, the child? Okay, the child has straight hair and it's uh albino. So straight hair is little c, and albino is little n. So where did the boy or a girl, I don't know, where does the child get the little c from? Well, one of the little c would be from the man, for sure, because you get one from father, and then the other one you have to get it from mom, which means the mother has to be hybrid. The mother has to be heterozygous. You can use the same argument for the little n. One of the little n's would be inherited from the mom, and the other one must be coming from dad. Right? So sometimes we have to trace the character through generations before we can decide the genotype of everybody in the family. What's that? I'm sorry? No? Okay. That is that. Okay. Um, we are going to, I mean, hopefully you understand now the monohybrid and the dihybrid. Now I'm gonna go through a pedigree with you, and that could be a little bit confusing. It's confusing in person. It's maybe even more confusing online, but I'll try. I'll try. Right? So basically, on the quiz, you will have pedigree questions where I show you a pedigree and then I'll ask you based on the pedigree. Oh, I should write down the word. Okay. Pedigree. Pedigree. Pedigree is a family tree. Okay. And based on the pedigree, I want you to tell me whether the trait that we're looking at is dominant or recessive. So let me give you a bit of a background, okay? Square is male, circle is female. And if you're not sure, like, if someone is pregnant with a baby, but they don't know if it's boy or girl yet, then we use, um, what do you call this shape? Diamond, okay, diamond. Okay, so this is not sure yet. Okay, and if you join them horizontally with a line, that means they're gonna have kids, and each generation is represented by a Roman numeral. Okay, so this is generation 1, 2, 3, 4, and each individual within that generation is going to be represented by uh, regular numbers. Okay, if we shade them in, then it is going to be, in this case, a male with the trait of interest. Okay. Whatever the trait is, maybe we're talking about like curly hair. Okay. So in this family, this guy has curly hair, this guy has curly hair, this guy has curly hair. Okay. Everyone else don't. So the question is curly hair dominant or is it recessive? That's what we're trying to figure out, right? And we will only be doing autosomal dominant or recessive, which autosomal means it is carried on chromosome 1 to 22. Okay. And then circle would be a female with the trait of interest, whatever you're looking at. Okay. I'm gonna ask you a few questions just to see whether you are with me or not. Okay. Uh, so this person right here, this person is 1-1. This person is 1-2. Okay. This person is like 3-5. You understand how to refer to them? And you use the Roman numeral on the side first to specify which generation, and then you use the uh, uh, I call them regular numbers, but they're Arabic numbers, right? To specify which individuals you're talking about. So, how many? What's the relationship between 2-1 and 2-3? How would you describe their relationship? What are they to each other? Someone please tell me. 2-1 and 2-3. What are they? Siblings, that's right. Very good. Okay, so 2-1 is right here, 2-3 is here. They are brothers and sister. Yeah, brother and sisters. You don't know which one is older. Doesn't matter. So that's good. These are siblings. Okay. What about 3-3? 3-3 and 2-5. 3-3 and 2-5. What's their relationship? Are they related? Yeah, very good. Yeah, so 3-3 is right here. 2-5 is here. So this one, 2-5, is the aunt of 3-3. Okay, so this is aunt and this is nephew. Okay, do you guys understand how to read the relationship here? Right, so on the test, if I asked you, right, what's the genotype of 3-6, then you have to know who I'm talking about. Okay. Now, based on this situation here, I want to know whether this is a dominant or if it's like a recessive inheritance pattern. Right? So only three people has the trait that I'm looking at. Okay? Again, doesn't matter what it is. Okay, could be curly hair, could be like with dimples, freckles, whatever. Okay, just one trait. Only three people in this whole family has it, and I want to know whether it's dominant or recessive. Okay, so this is recessive. I'm going to tell you this is recessive. And how do you know it's recessive? So recessive usually skip generations. Okay. Usually skip generations. You see, no one has it here, and then someone has it, and then next generation it's skipped again. Over here, nobody has it, and then someone has it. So it's not very prevalent in the family tree. Okay, it's not like everybody has it. I have it, my sibling has it, my cousin has it. It's not like that. Okay, it's like it's kind of spring up, here and there. It skips generation. So that's the first thing you're looking for if you have a family tree. Is this skipping or is it not skipping? If it's skipping, it's probably recessive. Also, another key feature is two um unaffected. We'll call them unaffected, okay? Unaffected parents can have affected children. Okay, so look over here. Both parents don't have it, but these are all their kids, right? One of the kids have it, right? Like, how do you explain that? How do you explain a situation where the parents don't have it and the kids have it? Well, the only way to explain is it would be like the parents are like big A, small a, big A, small a, then this is small a, small a. That's the only possibility, right? Do you understand? And then there's one more clue, right? Two affected. I say affected because usually we use these to look at diseases, okay, instead of like a particular trait. Like, anyways, that's why I say affected, okay? I'm not saying like curly hair is a bad thing or something like that, okay? But two affected parents. What can you say about two affected parents? If this is a recessive situation, what must be true for the kids of two affected parents? In other words, if both parents have it and we're talking about a recessive trait, what can you tell me about their kids? Can you tell me anything about their kids? For like for sure they will have it any, or do you have a percentage for me? Like half the kids will have it, quarter, 50%, 50, okay. Well, let's see. If both parents are affected, okay, and we are talking about recessive trait, if both parents are affected, okay, what's gonna happen? Well, if we are talking about recessive trait, then the parents must be little a, right? Little a. Recessive, right? That's what it means. Look, recessive trait, and to express the recessive trait, the person has to be homozygous, little a. And if you do the calculations, you will see that all the kids will have it. All the kids will have it, 100%. Right? So two affected parents will always produce affected children. Right? Remember I said the first time I taught you this, I was joking, right? I was like, if you really like a recessive trait, right, and you want your whole family to have that recessive trait, you have to find someone who also has that, right? And like if you like, dimples, which is recessive, then you find someone who has dimple, then the whole family is going to have dimple. That's what this means. If both parents are affected, if both parents have the trait, then all of the children are going to have the trait. Right? So these are three things that you look for to determine whether it's recessive or not.
I have a question.
Sure.
If the characteristic was dominant,
Mm-hmm.
is it possible to talk? Yeah. What is going to be outcome then?
Yeah, that's going to be the next question. All right. Yeah. No, hold on though. Okay. Very
Thanks.
good. Yep. Any question about this? Okay. So like if I give you a pedigree on the quiz, okay, which I probably will, you have to convince me whether it's dominant or recessive. Okay. Like you cannot be like guessing it. You have like if you just say dominant, you're not going to get any marks. Right? You have to tell me, okay, I think it's recessive because blah blah blah. Okay, or I think it's dominant because it's, X, Y, Z. Anyone confused before I move on to the other example? Okay. I I have a question. You're confused? Yeah. Do you have a question though, Manisha? Like it's
When you're explaining the trees, when you're
like
trying
this
to
one?
say the down one, the down.
Uh,
I still got confused with this chart, like skipping thing. You're saying that.
oh, like the meaning of skipping?
Yeah, but kind of,
Okay. So look, this is great grandparents, right? And actually here it's one big family, sure, but then it is actually three separate families, right? Okay. So like, that's like one family, and then this here is like another family, and then here is like, a third family, right? Do you understand that part? That it's like three families forming a big family. Yes?
Yes, that one,
Okay.
yes.
So, okay, let's focus on the left family here. The left family here, anybody has the trait in generation one? Nope. So it's no, 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 and then it shows up out of nowhere. That's called skipping generations. It doesn't show up in every generation compared to like the next one I'm showing you, right? It's not really skipping. Okay, so look, that's one family here. It's everybody has it here, and then people also have it here. It didn't get carried on to the third one, okay, but then it looks like it's more people having it compared to this one. Okay, so in this case, again, like no one has it, someone has it, no one has it. So it's skipping, right? It's coming up in alternating generations. That's what it means by skipping. And that alone is not enough to decide whether it's dominant or recessive. You also have to look at the other hints to see whether it support your idea of whether it's dominant or recessive. Okay. Well, let's go to the next one first. Maybe it will make more sense. Over here, um, this one, this one, first of all, it cannot be recessive. Okay, if I look at this, and then if I only have two choices, dominant or recessive, then I know for sure this cannot be recessive. Why not? Because over here, the third point, and what does the third point say? Two affected parents will always produce affected children. We look at this. If they're both little a, then guarantee the whole family is supposed to be little a, right? But in this case, we have two affected parents, but one of their kids does not have the trait. If this was recessive, then this here must have been shaded in. Do you understand? Right? It's not possible for it to be recessive because two affected parents has an unaffected child. Okay? So that's a hint for dominant. So first of all, uh, don't skip, no skipping, no skipping generation. Okay, generally more people have it in the family. Okay, so I know these people don't have it, but look, like it certainly looks like more people in the family has it. You can count one, two, three, four, five, six, 6 out of 12 people. So like that's 50% of the people have it. Over here, it is three people out of, one, two, three, four. How many here? Eight, 12, 16 people. It's 3 out of 16 people have it, right? Versus, 6 out of 12, right? So it's certainly a lot more people. And the nail in the coffin that shows you it's not recessive is that two affected parents have an unaffected child. Right? That's definitely not recessive. And also, all affected, all affected uh, 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 individuals must have at least one affected parent. Okay, copy it down first. I'll explain. All right. So, this is dominant, and you know this person has the tray. So that means is like capital A and something. I don't know what the other thing is. It could be big A, right? It could be big A, or big A, small a. We don't know. Okay. But what we do know is if the person has one big A, then this big A must have come from either the father or the mother. Okay? Must have come from the father or the mother, which means one of the parents must have the trait. Right? Over here, let's say this one is big A and something, and the big A has to come from, it should be the other way around, has to come from the father. Right? So at least one of the parents must also have the trait. Let me show you what I mean by that. Let's say I have someone like this. Okay, so no, that was wrong. There we go. Okay, this is not possible. Not possible for dominant trait. Okay, listen to me and see why. This person has the trait, so he's capital A something. I don't know the other one, doesn't matter. Where did he get the capital A from? Well, the capital A has to come from either the father or the mother. But if the father or the mother has the capital A, they too would have been shaded in, right? But I don't see them shade in here, right? It's not shaded in. So that tells you this is not dominant, right? Something like this is not possible for a dominant trait, right? So if you see this, it's not dominant. Just like the previous question. Look, I see a person with it, but then the parents don't have it. It's not dominant. Okay? All right. We're gonna practice, and you're gonna tell me what you think. Okay, I'm gonna launch the poll. Hold on. Don't say anything. Okay, go ahead. If you think it's dominant, choose A. A is dominant for the poll. B is recessive. Okay, if you're confused, just tell me you're confused. What do you think? Do you think this is dominant or recessive? Remember, on the test quiz, you have to convince me. You have to give me some rationale, right? Like why do you think it's dominant? Okay, pick something. All right. Okay, I have 8 answers. Anyone else want to choose something before I reveal the answer? All right. So the correct answer is dominant. Okay, dominant. Okay, for this one is dominant. How do you know it's dominant? Well, first of all, skip or no skip. What do you think? Looking at this, well, a lot of people like this generation has someone who has it, this generation someone who has it, this generation someone has it. It looks like it's not skipping, so no skip. If it's no skip, then it's probably dominant. Okay, probably dominant. But let's be sure, okay? Is there something here that tells me definitively it is not recessive? Okay, so no skip is dominant for sure. But is there something that tells me this definitely cannot be recessive? A lot of you got this right, okay? 80% of you who answered got this question right. Tell me, is there something in the tree that tells you it is 100% not recessive. Okay, that's fine. Let's go over here. Recessive. Two affected parents will always produce affected children. Okay, if you have two parents who are shaded in black and black in the pedigree, then all the kids will also be shaded in because of what I told you, right? If the parents are both little a, then 100% of the kids are going to be little a, right? Okay. Well, let's see over here. We have two affected parents. Okay, that's their kids. Two of the kids have it, but two of the kids don't. Right. So on the quiz, you will say, um, both parents in generation one are affected, but only half of their children are affected. This means the character, the trait is definitely not recessive. Okay, so we have the skipping. We don't have skipping. We know it's dominant. And then now we have evidence that it's definitely not recessive. So the answer is dominant. Okay, let's just try one more. Okay, let me see if I have a nice one right here. Uh, okay, let's do this one. Okay, same thing. I'm going to relaunch the poll in a second. All right, go, go, go. Anyone else before I tell you the answer? No? All right. Well, let's see. Skip or no skip? Okay. Yes skip. Okay. So if it's yes skip, is likely recessive. Okay. How do I know it skips? Remember, you can't just look at the whole generation like that. Okay. You have to look at the individual families, right? So like that's a family right there. Just trace the parents. So it like showed up, and then it's not there, and then it's there again. That looks like it's skipping. And then right here, we have like another family here. So again, it's like disappearing, right? And if you look at the far right here, it's there, it's not there, and then it's there again, right? So again, there's a little bit of skipping here. So it's likely recessive. Um, and then we look for other things that would either confirm it's recessive or something that would say definitely not dominant. Okay. So do I see both parents who are affected? Well, unfortunately, I don't have anything here. Okay, this is one parent has it, the other don't. Both parents don't have it here. One has it, one doesn't have it. So I don't have a situation that would show me this kind of pattern. Okay. But we can see over here, this is something that's interesting right here. Okay. And then also right here, these two things are interesting because, okay, because these families have affected children, okay, but neither of the parents are affected, right? So what does it mean? Definitely, definitely not dominant. Okay, definitely not dominant. Okay, how do I know it's definitely not dominant? Listen, if this guy has a big A, where did the big A came from? Did it come from the mom or dad? It has to be one of them, right? Right? Let's say it come from the dad. Well, if it did come from the dad, how come the dad is not shaded? If it came from the mom, how come the mom is not shaded? Right? So for it to be dominant, affected individuals must have at least one affected parent. So for that reason, this is recessive. Okay, I'm gonna leave it at that. There are more practice at the study guide. Okay, you know what? I'll pop in a few more. Just let you guys play with it. We can take them up in on Monday. Okay. I'm sorry, not Monday. When am I gonna see you guys again? Thursday. Thursday. I'll see you guys on Thursday again. Okay. So here we go. Okay. Um, I have like a whole collection of these things. I forgot. I'll leave it like that. You know what? Let's take a break. All right, let's take a break. If you want to try these, go for it. Let's let's come back at 1:37. All right. See you in a bit. Okay, let's learn one more thing here. Um, but before we go, anybody want to share what they think these are? Like, is it dominant or recessive? Anybody? All right, that's fine. I'll let you think about it. And you can ask me on Thursday when you see me. So just one more thing that we have to learn for the quiz. Okay, there's only not the entire lecture A is not going to be on the quiz. Okay, there's only just one more new thing that you need to know um, for lecture 8, and it is incomplete dominance versus codominant. All right, I'm just gonna copy the slides over here. Just 3 more slides. There we go. All right. So everything we've done so far is dominant versus recessive, where the dominant allele will cover up the recessive one and it will show up in a heterozygous condition. But it's not always like this. There are other characters that follows other inheritance pattern, like this one. Right? So we normally we would have like big R, which would be red, and then small r would be white. But in the case of codominance, or codominant inheritance pattern, big R, small r is going to be red and white at the same time. Okay, red and white at the same time. So that's called codominance. Right? What does it mean? The heterozygous genotype produces a phenotype that shows both both allele. Okay. So normally in a dominant recessive situation, the heterozygous condition would just be red, as red is dominant over white. But if they are co-dominant, then both would show up. Okay. And how do you know if it's codominance or not? The question will tell you. It's also possible to have another pattern, and this would be pink when it's heterozygous. So the heterozygous genotype, in this case, big R, small r, produces a phenotype that is a blend of both allele. And so it's not red, it's not white, it's somewhere in between. So I'll give you a human example for this. Okay, you can have a person who's type A blood, and then you have another person that's type B blood. And what do you think the blood type of the child is going to be? Type A blood, type B blood. The child is going to be? That's right, type AB. Right? So it's not just A, it's not B, it's both. Both shows up. Okay. Over here, an example would be like, I think it was Angelina, right? You asked me about skin color, right? So like you can have someone with um, darker skin tone, having a kid with someone with lighter skin tone, and then the kid, right? It would be somewhere in between, right? Okay, so that's uh, another example, skin tone. Okay? Height as well. Very tall person, not so tall. The kids might be somewhere in between. Are we good? All right, I hope so. Moving on. In Snapdragons, red flower is it's incompletely dominant over white. So you see, the question tells you this is incomplete dominance. Okay? The heterozygous condition produces pink flower. What will be the result of cross between two pink flower snapdragons? So let's see. Right? You probably should write it out. Right? So big R, like if you don't want to use R because it's confusing with the red and the white, you can just use other letters. Okay, you can go like big F is red, small f is white, and then big F, small f would be, in this case, pink, because the question said so. So we're going to cross two pink flowers, which will be like this. Okay. So go ahead, do the Punnett square. You do it the exact same way as before, okay? But you interpret the results differently. You interpret the results differently. So I'll give you a moment to fill that in, please. So over here is big F, big F, big F, small f, big F, small f, small f, small f. Okay, so what are the results? Well, I have 25% big F, 50% big F, small f, and 25% small f, small f. Okay, so I just look at this. That means 25% red, 50% pink, and 25% white. Right? Whereas if this was a dominant recessive situation, it would have been 75% red, right? Okay. But only big F would be red in this case. Right? If it's a heterozygous condition, because this is incomplete dominance, it's going to be somewhere in between. And that's how you get the pink. We good? Okay. One more. A red bull crossed with a white cow produces a roan calf. Okay, so what does that mean? A roan calf has intermingled white and red hair. Okay, so we have a red one and a white one, and now we have an offspring that has both white and red. We call that a roan calf. So this is an example of codominance. Both the red and the white hair shows up in the cow. Okay. So if a roan bull is crossed with a white cow, what percentage of the calves would be roan? So again, you can come up with your own alphabets. Okay, so like you can go big C is red, small c is white, and big C small c would be roan. What are we crossing? We're crossing a roan bull with a white cow. So that's big C small c crossed with a white cow. And we're going to go ahead and do it. So it's big C, small c, small c, small c, big C, small c, small c, small c. Just like a regular Punnett square. And so it's not difficult to see. This is 50% roan, big C, small c, and 50% white, small c, small c. I have a question for you. Let me just move this over here for a second. Okay, I'll post all these notes for you afterwards, okay? So if you haven't finished copying, that's okay. Over here, look. We started with 2 pink flowers, but only 50% of them are pink. What if I only want pink flowers? What kind of parents should I breed? How do I guarantee the highest yield of pink flowers? Or is 50% the highest we can get? What parents do I need to produce the most pink flowers? Anybody? No? Thank you. Yes. And what color is that, Annie? That's it. Okay. So if you take red and you cross it with white, right, this is going to be 100% pink. Right? You can do the Punnett square to verify, which is interesting, right? Having the two pairs that are the same is not always going to guarantee you're going to get the exact same thing. Okay. When it comes to things like incomplete dominance or codominance and stuff like that. All right. This is the end of quiz number 4. Okay, quiz number 4 has the mutation stuff from last lesson. What is it? Lecture 7. Okay, we have the mutation stuff from lecture 7, and then lecture 8 is only up to this portion. No meiosis, okay? No theories, right? It's just problem solving. Just problem solving. So you can save the meiosis stuff for the final test. Now I'm gonna teach you the last part of the lesson, and then I'm gonna let you go. Right. So the last part is called sex-linked conditions. Right. And in case you did not hear me, not on quiz 4. Okay. Not on quiz 4. I'm sure someone will email me and ask me if it's on quiz 4. It's not. Okay, it's not in quiz 4. But it's it's part of genetics, and we're gonna look at it. Okay. So let me just pull up the slide here. What does sex-linked condition means? Well, we have two sex chromosomes, XX for female and XY for males. And if the gene for the trait is carried on chromosome 1 to 22, then we say it is autosomal inheritance, okay, which is everything we've done so far. With the curly hair, straight hair, dimples, no dimples, freckles, right? All those kind of stuff, those are inherited from chromosome 1 to 22, and they are autosomal inheritance, okay? But some conditions are transmitted on sex chromosome only. And if it's transmitted on the chromosome X, then we call it X-linked conditions or X-linked disorders. Examples of those include hemophilia, which is a bleeding disorder. Your blood don't clot easily when you have a cut. That's hemophilia. And color blindness, okay, red-green color blindness. Okay, so that's another one. Both of these are recessive. Okay, recessive X-linked disorder. Right? That means both copies of the X's has to be mutated before you have the conditions. If you are a woman, right? For men, because we only have one X, so if we inherit a mutated X, then we are going to have the condition automatically. Okay, I'll write them down for you in a bit. What number do you guys see here? Do you see any number? You can tell me, you can type it out. What number do you see? Do you see 74 or do you see 21? Okay, if you see 74, then you don't have red-green color blindness. If you see 21, you probably have red-green color blindness, and you probably would know about it already. It's something you're born with, right? It's not like you will catch it or develop it later on in life. So if you don't have it, then you don't have it. This is called the Ishihara test. It's for testing for color blindness. Okay, red-green color blindness. people cannot distinguish between red and green. There are other forms of color blindness as well. Okay, so let's go through some sex-linked basics here. Okay. I'm just gonna use color blindness as an example. Okay, use color blindness as an example. It's easier for people to relate to this. And color blindness is X-linked recessive. Okay. So for X-linked recessive, men are usually more affected than female. Right? Generally, more males affected than females. Why? Because female has two X's. So if they get one bad X, no problem. The normal one will cover it up because it is recessive. Men only have one X, so if we inherit the bad X, we automatically get the condition. For X-linked dominant is the other way around, right? More females will get affected than males for X-linked dominant. Why? Because now the the extra X chromosome for female is no longer serving as a protection. It's more like a liability, right? You have two chances of inheriting a bad X. Either one can cause you to have the disease, right? Whereas men, you only inherit one X, so you're okay if you don't get the bad one. Right? So this is for X-linked recessive, is the other way around. The other way around for X-linked dominant. Okay. And if it's Y-linked, then only men can get it, right? All right. So let's do color blindness. This here is a male with normal vision. Male with normal vision. And he's gonna be XY. Sorry. XY. Normal X and normal Y. This here is gonna be a normal, a female with normal vision. Right? If you shade it in, then this is X. We can put C here, XCY. So this XC is the colorblind X chromosome. So this man is colorblind. Male with color blindness. Right? Like I said, the man only has one X. So we get the colorblind X, we're gonna be colorblind. Okay. This one would be a colorblind female. How does a female get have color blindness? What would be the genetic makeup? What's the genetic makeup for a female who is colorblind? Well, since this is recessive, the only way for the female to be colorblind is if she has two copies of the bad X, right? Of the mutated X. So this is female with color blindness. How about this last one? What do you think? Okay. A, if you think it's colorblind. B, if your thing is normal. A for colorblind, B for normal. This person right here. Okay, so we see one disease X, one colorblind X, but then she also has a normal X. Because colorblindness is X-linked recessive, the normal X will cover it up. So she has normal vision. Okay? But when we draw them, we shade half of it in. Okay? We shade half of it in because we call these a carrier. Okay? A carrier is a person who has the disease allele, but does not actually have the disease. Okay? They have the colorblind X right here. They have the colorblind X, but they do not have color blindness. That is a carrier. Can men be carrier? What do you think? I don't have color blindness, but can I be a carrier of it? No, right? Because we only have one X. Men only have one X. You have the colorblind X, you're gonna be colorblind, right? You're not gonna be like hiding the the colorblind X chromosome, right? But the female can hide it, not like deliberately, like you know what I mean? Like it's hidden because the normal X is covering it up, right? For men, there's I don't have one to cover up. Okay. Another interesting thing to know is, okay, you got to think about this. Colorblind males, colorblind males, um, do not pass the mutated X to their sons. Okay, they can only pass it to the daughter. Right? To have a son, you pass on the chromosome Y. To have a daughter, you pass on the chromosome X. Okay. So if the son is colorblind, it's from the mother, for sure. All right. Let's do a few examples, and then we'll be done. First one right here. Carrier female with a normal male. We're talking about colorblindness here, okay? So carrier female, that's XXC. And then normal male would be XY. Then we just do the Punnett square, like normally. Normally. So that's the mother. And then the father. Put the X's together. Same thing. So for these questions, we usually look at the boys and the girls separately. And so these are the girls. What's the chance of the daughters being colorblind? Help me out here, guys. What's the chance that a daughter from this family will be colorblind? Okay. Anyone else? How do you decide which side the XC is on beside the, oh, like you mean this versus this? Is that what you're asking? Yeah, it doesn't matter. Up to you. It's not gonna affect the result. Okay, I need to know if it's a daughter here, what's the chance that they're gonna be colorblind in this family? %0 chance. Okay. This is normal vision. This is a carrier, but she doesn't have color blindness. So all daughters will have normal vision. How about sons? Okay, look at the sun. Right? Just the sun. 50% sons, normal. 50% sons, colorblind. It's not 25% because we're not looking at like all the kids, right? We're only looking at the boys. Okay, there are only two squares for the boys, and one of them is colorblind, the other is not. That's why it's 50%. All right, I am gonna let you try one more before we go.
One question.
Hmm.
Test is on Tuesday, yeah?
Next Tuesday, yes.
Yes.
Quiz, yeah.
Are we go
What's that?
are we going to practice next class for the test or
No, no practice. I already gave you a practice package, the pink one, remember?
yes, you
Yeah,
did. Yeah.
and the answer is online, right?
Okay. Thank you.
Yep. Okay, do this. I'll give you a couple minutes and I'll take it up with you. All right, let's take it up. We have a normal male here, which is going to be XY, and a colorblind female, which would be XCXC. For the female to be colorblind, both X chromosomes needs to be mutated. And so we're going to go ahead and do the Punnett square one more time. And we're going to put X and Y on the side this time. Again, it doesn't really matter. You know what? Let's just be consistent. Let's just put the guy at the top here. And then we're going to put the female here on the side. Again, it doesn't really matter. I'm just doing it the same way as the other one. So, people don't get confused. And it's going to look like this. Okay. And if we highlight the females here, what's going to happen to the females? Are they going to be colorblind? Are they not going to be colorblind? What's the deal? Well, they are all going to be carrier, but they will have normal visions. Okay. So again, I'm just gonna copy it from here. All of them will have normal vision, even though they're carriers. Okay? And then for the sun, 100%, 100% sons with color blindness. And that's what I was trying to tell you. If it's a recessive trait, more males are affected by than females. More males are affected because for males, you only need one mutated X for the disease, for the condition to show up, not just for color blindness, but for other X-linked condition as well. If it's autosomal, then it doesn't matter. Autosomal means it carries from chromosome 1 to 22, then it affects males and females the same. It doesn't really, matter. But if it's sex-linked, if it's X-linked recessive, more male will end up having it. Okay, that is all. Please work through the study guides. If you have questions, you can send me an email. I can come to class a little bit earlier on Thursday, and then we can sort it out. And we are also doing lecture 9 on Thursday. So please print the stuff. Okay. Thank you for switching to online for me today, and I will see you all on Thursday. Bye bye.